All right, so I think we've looked at, or you may have looked at, solving equations by graphing, and they say graphically, but really they mean by graphing electronically. So either using a graphing calculator or a website or software to graph your equations. So I think we've all done this, I think. And I have a couple of a couple of steps and then a couple of resources if you want them. I've also put them in the additional resources folder in Schoology. So if you don't have your own graphing calculator, you can look there at places where you can access a graphing calculator. So basically, when we're solving equations by graphing, we're going to take whatever's on the right-hand side of the equal sign, should be a sign, not side. That's why I don't teach English. And graph that as one equation. So if you're using the Texas Instruments calculator, whatever's on the right-hand side might be your Y1. Whatever's on the left-hand side of your equal sign would be your Y2. And then find where they intersect. And those points of intersection make your solutions. All right, so if we had, one of the disadvantages of using a calculator is when you graph and solve, you will only find your real solutions. So any solutions that we found in the past that were like, well, yesterday we had 1/2 plus or minus I times the square root of 3/2. That won't show up on a graph because it's an imaginary number and your graph will only show real number solutions. So just be aware of that. So we might not have, even though we have maybe an equation of degree 4, we might only have 2 solutions. So just just saying that so that you know as we work through. All right. Your textbook is going to ask that solutions are rounded to 3 significant digits rather than saying rounded 2 decimal places. They're going to talk about significant digits, although I think for most of these problems, that's going to be like 2 decimal places. You might have one number in front of the decimal. So, but we can talk about that as we work. X to the 4th plus x cubed equals 4x squared plus 4x minus 5. So if this has all real number solutions, how many solutions will we have? Yeah, 4. And we'll see here in a minute. So I'll share this in a minute. All right, so share my calculator. A little bigger screen. There we go. So there are my 2 graphs. I love the color edition because it shows it in color, so it'll differentiate between the 2. And I use the normal window. I did a zoom normal. Okay. And it looks like we have just one point of intersection. And we might have another one up top here, but I'm going to actually zoom out quite a bit. I'm going to change my Y's to go from 0 to 20 and see if that actually was another point of intersection in there. So finding the points of intersection, second trace, option 5, first curve, second curve, and then I would need to make a guess. I think it's right about there. And so 3 significant digits, I would round this. This would be 0.825 as my estimated solution. 0.825 would be a possible, or would be one of my solutions. And I'm using the approximate symbol there because it's not exact. And then I have another one up a little higher. That's an intersection. So again, first curve, second curve. And one of the things to be careful of is if you're too close to that first solution, that first point of intersection, it won't find the second one. So you need to make sure, this is one of the few times on the graphing calculator where you need to be kind of close to what you're looking for. And that one says 1.71 if I round for 3 significant digits. Okay. Now, a couple of things with this function. x to the fourth in general is going to have the same shape as x squared. So I can be pretty confident that I'm not going to find any more solutions. Just two in this case. All right, so just two solutions for that one. Just two real solutions for that one. I should be a little more careful with how I say that. All right. So there could, I mean, one of them could occur more than once, or we could have a couple of complex solutions, which we can't find by graphing. All right. The second set, x cubed plus 3x equals 10x squared. Now I can't remember what my x cubed plus 13x. Equals 10x squared. Whoops. 10x squared. No. Let's try this again. 10x squared. There we go. All right. And I'm going to switch back to my standard window. And that's where I would always start. All right. I want to double check. X cubed plus 3. Okay. All right. So again, I think I'm going to change my window a little bit because there could be a solution higher up at a larger y value. And I can kind of see here that they're starting to maybe intersect at the top. So let's find this first point of intersection. Anyone want to take a guess at what x value this is going to be? 0 would make sense, right? And if you look at the equation, if I plug 0 in for x, what would I get? 0, right? 0 equals 0. That's a good thing. Emma, you're looking like. Okay, let me take a look. It could be the minus wrong too.
Because it's x cubed.
Did I miss? And it could be that I hit a wrong button. X cubed plus 13x.
Yeah.
All right. Let me just clear mine out once. X cubed plus 13x. Let's see what yours looks like. Okay, and it might be. That's okay. So what I would do is just go zoom and choose option 6, zoom standard. And does that look a little?
Oh, there we go. There you go.
Okay, good. So let's find this first point of intersection. Second trace, intersect. 1, 2, and we're pretty sure it's right there. And indeed it is. 0 is a solution. We'll write that one in a minute. This other one, I think, is a little bit higher than what my screen is. So I'm going to extend my y-axis a little bit. I'm going to go with a max of 35, and I'm going to count by twos. Yeah, and there, I think we're fine. I think it's right here. Bam, it's right there, Mr. Gingrich. There's the solution, but we can't. We have to be a little more exact than that. So calculate the point of intersection. 1, 2. And my guess is going to go up here. At 1.54, again, 3 significant digits. Okay. And I guess I should be a little more careful. That is exactly 0. That is an approximation. All right, so a couple of graphing calculator websites and things that you can use. Desmos.com is actually really slick because like you can touch where you think the point of intersection is and it will find it. This website, the minnesota.pearsonaccessnext.com, is the website that has the TI-83. I think it's the color edition, but it's the one that they use for the MCA test. So it just takes, and there are directions again in Schoology of how to get there. The textbook uses this mathisfun.com. The thing that I don't like is for that one, it doesn't actually find the points of intersection. You have to zoom in until you find the points of intersection, which I think is a lot more work than it needs to be. So my recommendation would be, if you don't have your own calculator, using the Pearson Access Next or Desmos. I think those two work really well. There is an app that you can download on your phone that is a Texas Instruments, and I think you have a choice whether it's an 83, 84, or 84 color edition calculator. And again, those directions I did put in Schoology. So if you want to look at those and use one of those, you can do that. And there we go.